This is for Algebra 2, and this is day 1 of logarithmic functions. This is a new unit, but it ties in very closely with the exponential unit we just finished. In logarithmic form, an equation looks like y equals log base b of x. Y equals log base b of x is how you say it. The same thing in exponential form is x equals b to the y power. To change between the forms, you're just moving things around. Your base is always the base. So here your base is a little subscript. Here your base is what holds the exponent. So your base stays the same, and then the other two numbers just swap sides. So if we change these following from logarithmic to exponential, log base g of 1 is equal to 0. G is still your base, and 0 becomes your exponent. So this is g, I'm sorry, that was 8, not g. 8 to the 0 equals 1. Log base 4 of 16 equals 2. Becomes 4 squared equals 16. Log base 2 of 1/16 equals negative 4. Your base is 2, negative 4 becomes your exponent, so 2 to the negative 4 equals 1 over 16. Log base 3 of 1 over 27 equals negative 3. 3 is your base, negative 3 becomes the exponent. 3 to the negative 3 is 1 over 27. So going from logarithmic to exponential, sorry, that's a typo. Going from exponential to logarithmic, your base is still your base. The base becomes the little number. So if we have 10 to the third, it becomes log base 10 of 1,000 equals 3. Okay, your base stays your base, and then the other numbers swap. 4 to the third equals 64 becomes log base 4 of 64 equals 3. 9 to the 1/2 equals 3 becomes log base 9 of 3 equals 1/2. 125 to the 1/3 equals 5 becomes log base 125 of 5 equals 1/3. Okay, so if they give you a logarithmic expression and want you to evaluate it, for example, they say evaluate log base 2 of 64. The first thing you want to do is set it equal to y. You just add that to the end of the problem. Then you rewrite it in exponential. The base is still the base. And you can either write this 64 equals 2 to the y, or you could say 2 to the y equals 64. It means the same. I'm probably going to do it the second way most of the time. Rewrite it so they have the same base. So we've got a 2 for our base here. We've got to find this to be a 2. So 2 to the 6 equals 2 to the y. Set your exponents equal to each other and solve. So we figured out that y is equal to 6. When you write your answer, you're going to take the original part, and then you're going to set it equal to what you solved for. So let's look at one. If we're going to evaluate log base 3 of 81, the first thing we're going to do is tell ourselves that it is equal to y, and then we're going to rewrite it in exponential. So equal log base 3 of 81 equals y. This becomes 3 to the y equal 81. Got to have a common base, so it's both going to be 3 to something. So 3 to the y is equal to 3 to the 4th. Set your exponents equal to each other, and you end up with y equal 4. So then your final answer is log base 3 of 81 equals 4. Number 10, log base 4 of 256. This becomes log base 4 of 256 equals y, which becomes 4 to the y equals 256. You got to find a common base. 4 to the y is equal to 4 to the 4th. Set your exponents equal to each other, and y is equal to 4. So your final answer is log base 4 of 256 equals 4. Going to the next page. If they want you to solve a logarithmic equation, they've given everything to you and you're just solving it. First step is rewrite it in exponential. 4 is still your base, and then you swap these other two numbers, and it becomes 4 to the 5/2 equals n. Then you got to remember what we learned in the exponential unit. Anything to a fraction power is going to end up being a root. Okay? So this would be the same thing as saying the square root of 4 to the 5th. Okay? Or they went ahead and broke the base down, 2 squared. Instead of saying 4, they said 2 squared to the 5 halves. Then they multiplied their bases, which would get you nowhere, in my opinion. I think it's really easier at this point to use my root thing. And you need to realize you could also say it is the square root of 4 to the 5th is equal to n. The square root of 4 is actually 2 to the 5th is equal to n. Calculator 2 to the 5th, and you get 32 is equal to n. I really think that's probably the easiest way to do this. Let's look at some down here. You're going to rewrite it in exponential, and this becomes 9 to the 3 halves is equal to x. You're going to break your base down, and it's 3 squared to the 3 halves is equal to x. And so then they're saying this becomes 3 to the 3rd, and where it's coming from is that when you multiply a power to a power, 2 times 3 over 2, your 2's cancel, and that's where the 3 is. So then 3 to the 3rd is equal to 27, okay? Which is actually going to tell you where all this came from. This right here is just multiplying power to a power. Either way works. What they're doing here or what I showed you, it's not really going to matter. What's important is that you get the answer at the end. So log base 16 of x is equal to 5 halves becomes 16 to the 5 halves equals x. You could rewrite 16 as 2 to the 4th. You need to break it down to the smallest base possible. Don't break that down just to 4. So then you're going to say power to a power means multiply. So 4 times 5 halves gives you 10. So 2 to the 10th is 1024 is your final answer. Okay, this 10 came from saying 4 times 5 halves. 2 goes into 4 2 times, and 2 times 5 is 10. That's where that's coming from. Going to the next page. Right here, it just wants you to kind of refresh your memory. Change it from logarithmic to exponential. So this would be 5 to the 3rd equals 125. This would be 4 to the negative 1 equals 1/4. 5 to the negative 2 is, 1/5 to the negative 2 is 25. You're just moving things around. Changing it from exponential to logarithmic becomes log base 8 of 512 equals 3. Log base 5 of 1 over 125 equals negative 3. That's a typo. It should be a negative. Log base 2401 of 7 equals 1/4. You're just moving things around. So let's evaluate these. You're going to set it equal to y. So this becomes 2 to the y is equal to 16. 2 to what power is 16? And you can just trial and error it in your calculator and you'd get 4. This is going to be equal, and you can put x, it doesn't have to be y. 9 to the x is equal to 243. Well, we know that 9 times 9 is 81, so probably want to try 9 to the 3rd. And it's 729, so that tells me we got a problem. So we got to break this 9 down, and it becomes 3 squared to the x is equal to 243. So this is 3 to the 2x is equal to 243. So 3 to what power is 243? Trial and error, I would start with 3 to the 5th, and I got it. Lucky guess. So 3 to the 5th is 243. So this means 3 to the 2x is equal to 3 to the 5th, which means that 2x is equal to 5 divided by 2, x is equal to 2.5. Okay, that one's not as clear. I kind of went around the world with my writing. But look back and see if you understand what steps. You've got to break that base down as small as you can. Then you multiply your powers, and then you've got to figure out how to get the same base on the other side. So log base 9 of x is equal to 2. You would rewrite this. 9 squared is equal to x. You could punch that in your calculator and you would get 81. 25 to the 3 halves is equal to x. That's the same thing as saying 5 squared to the 3 halves is equal to x. You have to multiply your powers, and so 2 times 3 halves, your 2's cancel, and you end up with 5 to the 3rd is equal to x. And so you have 125. Okay, that's the end of your notes. That ought to take you to an assignment. There are practical uses of logarithms. When you're talking about decibels, okay, we're talking about music here, sound, noise. Seismology, when they study the earthquakes, they use exponentials. So that has you at your assignment. If you have any questions, call me over.